Hello students, welcome back to CS session. In this particular session, we are going to learn about linear search algorithm. In the previous class, we have learned there are two algorithms. One is a traversing algorithm, another one is, it's not an algorithm, in the simplest manner how you are calculating the length of the memory block. And those two are very important for 3 marks for your exam, and this will be asked for 5 marks. And here I have defined so many steps with followed by a particular statement, and each and every statement how it will work to find or to search a respected element in the memory block. Why I have mentioned each and every steps, each and everything I am going to write here. Please be careful while explaining the particular algorithm. Okay, I'm going to explain each and every line in detail, and that is I'm going to implement here as a working pattern. Before I write a working pattern, let me give the definition about linear search algorithm. We know the definition of algorithm. Algorithm is a step-by-step procedure of solving a problem. Yes, each and every statement I have defined with the different steps. In this particular algorithm, total 5 steps I have defined. So this the systematic approach to write the algorithm. And such meaning is that find the respected element or the required element from the memory block. And linear means in which manner, in which method, in which way you are going to find that required element. The linear indicate before searching an element, you just remember the one protocol that you are supposed to search in a sequential manner only, one after the another. You are supposed to search the value one after the another. You have to move from beginning to end value. There is no jumping statement to come in between in the memory block. You are supposed to go in a sequential order. Linear is nothing but sequential. Sequential means one after the another. So whichever the element you want to search in your memory block, you are supposed to start to search from the beginning to end. So that is the meaning. How you are going to write in a single statement? It's a process of searching the respected element or a required data items from the memory block in a sequential manner called as linear search. Now, we'll see the working pattern of this particular algorithm. Here you just make it as working pattern. Working pattern of this particular algorithm. Here first I have defined location equals to -1. So why I have started with the -1? Why not with the 0? I clearly told in the last class, when you start reading any element from the memory block, you are supposed to define the array, right? You have, this is the array memory block. 10, 20, 30, 40, 50. These are the items in the memory block. These are the items in the memory block, and execution of these items start from 0 because array execution start from 0. But when you are calculating the length of the array, it's supposed to start from 1, 2, 3, 4, 5. So when you calculate, the length of the memory block is 5 because the normal execution starts from 1, 2, 3, 4, 5. But compiler starts its execution from 0 only. Please be careful. Location equals to -1. So -1, this plus 1, it becomes a 0. Fine. When the compiler comes here, -1 plus 2, that becomes an 1. -1 plus 3, that becomes 2. -1 plus 4, that becomes 3. -1 plus 5, that becomes 4. Array executions are 0, 1, 2, 3, 4. Because I want to search the element in this memory block with the support of this location only, not with these things. Why? Because compiler always consider array execution only, not the normal execution. But to calculate the length of the array, we need to follow these steps. 1, 2, 3, 4, 5. But to execute the compiler manner, we will just refer array execution that start from 0, 1, 2, 3, 4. If I want to go to the 0th location, I cannot write this as a 1. I have to write it as 0. How I have to go? Then you need to mention here minus 1. Minus 1, this plus 1 will be 0. I will come here. Next, minus 1 plus 2. If I want to reach to the second block, the minus 1 will be common. But the normal number is 2. Minus 1 plus 2, that will be 1. In the same manner, minus 1, 3, 2. Minus 1, 4, that is 3. Minus 1 plus 5, that will be 4. So if you are getting a confused, even you can write in this manner. So 1 minus 1 equal to 0. 2 minus 1 equals to 1, 3 minus 1 equals to 2, 4 minus 1 equals to 3, and 5 minus 1 equals to 4. I am taking this one in this particular line. The left side column I have taken minus 1, 1 is 0, minus 1 plus 2 as a 1, minus 1 plus 3 as a 2, minus 1 plus 4 as a 3, minus 1 plus 5 as a 4. But even you can take first this element, then this element. First, then this. First, then this. First this, then this. First this one and this one. In the right hand column, I have considered these elements as a first. 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. 4 minus 1, 3. 5 minus 1 is 4. So here why I have mentioned location equal to minus 1. I want to reach each and every memory block without fail. For that reason, I have defined here location equals to minus 1. Now, let me have the same memory block. Let me have same memory block. And that memory block I have defined here. The same thing I am going to write here. 10, 20, 30, 40, 50. Array executions are 0, 1, 2, 3, 4. Fine. The location minus 1. Why? Because minus 1, 1 will be 0. 2 minus 1 will be 1. 3 minus 1 will be 2. 4 minus 1 will be 3. 5 minus 1 will be 4. Right? This is the normal thing what I have defined here. Because we need to go for this location. Next, step 1. This is finished. Step 2, I have defined for p equal to 0 to n minus 1. For p equal to 0 to n minus 1. Where your searching element supposed to be between 0 to n minus 1. I will take this 0 as 1. Same. N means number of elements present inside the memory. How many? 1, 2, 3, 4, 5. So 5 minus 1. So 0 to 4. The p value comes between 0 to 4. Where you are going to search the element between 0 to 4. The same thing I have defined here. P equal to 0 to n minus 1. N means number of items present inside the memory block. There are 5 elements. There are 5 data items present. So that same 5 I have taken here. Minus 1 means 5 minus 1 is a 4. This 0 will be common. So 0 to 4 you are supposed to search. Fine. Now, I want to search this 40 element. I want to search as a 40. Now, searching element is 40. Consider searching element is 40. I want to searching element is 40. Kuzgole, one thing you remember. You cannot go directly to the third position. This is the linear search. You must and should visit each and every memory block. That is to be from beginning. Why? Because you are mentioning here clearly, I want to search the element from 0 position to 4th position. Now your searching element is 40. Now we need to print the 40 is available in the position 3. That is search successful. Step 3. This is step 1, this is step 2. Fine. Now step 3, what I have defined, if A of P equals to element, then that itself a location. Okay. Take, this is array name A. First position name is how much? 0 equals to element A of 0. Searching element is 40. A of 0, what's the value? 10. Is 10 equals to 40? Are you searching this 10? No. Condition is doesn't match. Condition doesn't match. You are searching 40, but that 40 is available in another position. But you have searched in the 0th position. Here, the searching element is not available. So, compiler what it will do? It will end the if, but it will not end the for. Why? Because only this block I have checked. Still 3 more left. Still few more left, right? I have to go to the next moment. So for that reason, it ends the if, but it doesn't end the for because condition is true. For loop P 0 is to 4. 0 is lesser than 4. Condition itself a true. So it will go back. If it is, this one is like this. P equal to 0. P is lesser than or equal to n. P plus plus something. P equal to 0, P is lesser than n, P plus plus. We know n value is 5. 0 is lesser than 5, condition is true. So, but 0th position, searching element 40 is not available. Now, P plus plus 0 plus 1, how much it is? 1. Now, 0 it will move, it will take it as 1. Now, same if statement, if A of P equals to searching element, A of P means how much? 1. Searching element is 40. A of 1 there. 20. Is 20 you are searching? No. I am searching 40. But in the first position also that is not available. So again it will end the if but go back to the 2 time it goes. This is first, this is second. Now one more time the P value is going to be changed. That time it becomes 2. That time it becomes 2. So if A of P equals to element, A of P means 2, searching element is 40. A of 2, 2 on yesterday, 30. Is 30, are you searching? No, I am not searching this. So that is not a location. That is not a location. Again it go back, then P value becomes 3. P value becomes now 3, right? So if A of P equals to element A of 3. A of 3. Searching element is how much? 40. A of 3 and 40. Check ಮಾಡಿ, sorry. A of 3 and how much? 40. Searching element is 40. When you find this particular searching element, compiler will execute this particular block. That itself a location equals to P. So 3 location is 3 and position also 3. Both are same. Location is also 3, position also 3. Condition match. Once the condition match, compiler ends here itself. End the for and comes to here. In which location it is available? Third location. Is 3 is greater than 0? Yes. Condition is true. So search will be successful. This is how the algorithm will be defined. So one more time, I am going to write the same thing. Please be careful. Okay. The same thing. The same thing. Okay. It's very, very important. You need to understand the things. So that's why I'm revising this one. But in coming algorithm, I will not write again and again in a twice manner. Only one time I will write. Fine. We'll see the memory block. That is array as 10, 20, 30, 40, 50 and the positions are 0, 1, 2, 3, 4. Okay, searching element is 40. I am searching element as 40. So location equals to -1. So -1, this 1 2, 3, 4, 5. Minus 1 and this one, that becomes 0. It starts from 0. Then for p equal to 0 to n minus 1, we have written here in the step 2. So that is 0. N means 5, number of element, minus 1. So 0 to 4. So p is supposed to work between 0 to 4. Next, come back to the, we'll start working searching element. If A of P equals to searching element, the first position hingandre. So idu innondu sari ಹೇಳ್ತೀನಿ. I am going to write one more time ಕೂಸ್ಕೊಳ್ಳಿ. It's mean in the programming P equal to 0, P is lesser than N, P plus plus. In the program we are going to write in this manner, but in the algorithm we will write in this manner. Okay. P first position value how much? 0. Searching element is 40. A of 0 how much? 10. Are you searching 10? No. Condition is false. So that is not my location. That is not my location. So it will end the if first time. It ends and it go back to the same position. That time P value becomes 1. That time P value becomes 1. So if P equals to if A of P equals to element, P means 1, searching element is 40, A of 1 how much? 20. Are you searching 20? No, condition is false. Second time the end if will be terminated and it will go back to the again a for loop. It will go back to the for loop. So that time P value becomes 2. P value becomes 2. If A of P equals to element, A of 2 searching element is 40. What is the value of 2th position? 30. Are you searching 30? No, condition is false. Third time it is going to be terminated and loop will go back to the for loop. So that time P value becomes now 3. If A of P equals to searching element, P means 3, searching element is 40. So 40 equals to 40, you are searching the 40 itself. So compiler immediately instruct your searching element itself 40. Then this particular statement will be get executed. That is location equals to P. Location is 3 and searching position is 3. Condition is true. Once this condition becomes true, go to step 4. Compiler becomes to step 4. What is that? Step 4. If location is greater than 0, my location is 3. 3 is greater than 0. Condition is true. So the search will be successful. This is how the program will be get executed. Fine. This is the working pattern. In the exam, no need to write the working pattern. You need to write this step. This will be asked for 5 marks. Linear search. Please find out in this particular explanation. I have read each and every memory block until and unless I get my respected element or a data item from the memory block. Once I got my respected element, just I have terminated and I came out from the memory block. Then the things are got executed. First I have started with the 0th position. In the 0th position I am unable to get my searching element. Then I move on to the first position. In the first position also I am unable to get here. Then I move on to the second position. Here also I am unable to get. Then I move on to the third position. There I am able to get my respected element. Then search becomes successful. I am searching that location itself. Here I have made it as a true. Then I am just finding the condition 3 is greater than 0. Yes, search is successful. You will get the position search is successful. Successful on location 3. This is the output what you will get. Hope all of you understood this particular algorithm. In the next coming class, I will teach one more algorithm. Please go through with this particular thing in your notebook, in your classwork. Please write down this working pattern also. If you are not going to write this working pattern, and when you start reading later, you are unable to understand how this works. In exam, you write this much only, but for understanding purpose, you need to write or copy this one too. And on linear search, you have one lab program. That program also will be explained. Before that, you just understand this algorithm. Fine. Hope so all of you understood this particular concept. Thank you.